Hello, everybody, and welcome to a Picterra product webinar. My name is Monika Łebkowska, and I'm a product marketing manager here at Picterra. And I'm really excited for you all to join us here today. Well, today's session, we will guide you through some of the latest updates and developments when it comes to new features that we've released in our platform in the recent weeks and months. And we will also give you some hint into what we're working on next. So to get started, I'd like to introduce our main speaker for today. I'm joined here today by Julian, our CTO. Hi, Julian.
Hi.
Here he is. Julian has been with Picterra since the beginning. He is the technical mindset behind the platform. He's been building the platform from the start. He has a strong technical background and experience in both software engineering, but also machine learning and geospatial analysis. And to go through quickly the agenda for today. So we have about 45 minutes. The first part we will take for a presentation that Julian will be delivering. It will also include a part with a live demo session. So he'll log on into our platform and actually show you in real time some of those features that he'll be describing. We will start off with the short overview and just a quick summary about our company and the platform. Then he'll move on to the actual core of today's session. So he'll present all sorts of different features within the new collaboration suite that we've recently released. He'll also show some other updates and improvements we've done in the other areas of the platform, like for instance within data management or detector settings. And then we'll finish off with a couple of minutes Q&A. So please use the chat box that you see in the corner of the screen to put your questions anytime during the event. And I hope we can get to as many of them as possible. And last but not least, the session is recorded. So following on when we finish, you will receive an email with the link to the recording, as well as the slides that we're going to be using today. And I think with that, I can hand over to Julian.
Cool. Thanks, Monika, for the introduction. So very happy to be here with you today. I think, as Monika said, we have a first quick presentation and overview of the platform, and then we'll go into a live demo, demoing some of the cool feature we've been working on in the past few months, really. So before we do this, I just wanted to take a bit of a step back and kind of re-explain what we are doing at Picterra. Not all of you might be familiar with what we offer. So Picterra is a software platform for geospatial machine learning. So what this means is that it's a cloud-based product in a software as a service model, and it's a platform basically where you can do all of your geospatial machine learning project. So we have an annotation UI, we have a way to train machine learning models, and so on and so on. And we'll go a bit into the details afterwards. We are very much imagery focused, as you can tell from the screenshots here. So we handle mostly geospatial imagery. But if you have a geospatial imagery machine learning project, we are really the platform for it. If you look at what we cover, we like to compare to the traditional flow you have in a machine learning project. So if you look at a typical machine learning project that is conducted by a team of data scientists, maybe with the help of some GIS analyst, usually you have a lot of phases and a lot of steps. So you have all of the steps at the bottom here. I won't go into all the details, but basically you have on the left-hand side, you have the whole data organization, data labeling, data preparation side of things. Then at some point you train a model, or the data scientists, they will train a model, they will evaluate it, and then you need to deploy it to production and kind of make it available to the organization at large. And then after that, you can run the model at scale in production and then get results out of the model. So for example, here we have results on a country scale. I think what's important to take away from this is that this is a workflow. If you do it the traditional way with a data science team, there is a lot of point in the flow where it can fail, basically. And what we see is that very often the project, they don't make it past the deploy to production phase. And this is because it's very hard to kind of transition a machine learning model from a data science team to a DevOps / software engineering team. there is a lot of things that can go wrong and that very often go wrong. And so this is why at Picterra, we cover really the whole flow. So we have an annotation, tool, we have a automated model training, but we also, all the model that you build on the platform, they are automatically available in production. So there is no deploy to production step and so on. So it's all fully integrated in one single platform. And I think that's really the strengths of what we provide. If you look at the platform, a bit where we sit, let's say in the general geospatial environment and workflow. So on the left hand side, you have the typical geospatial data. So it can be RGB data, it can come from drone, from satellite, from plane, but we go beyond RGB. So if you have infrared, multispectral, hyperspectral, SAR, elevation data and whatnot, as long as you can kind of represent it as an image, you can put it on Picterra and we can connect to it. We also support connecting to different kind of data storage, and I will go a bit more into this during the demo. But we try really to be able to ingest any kind of geospatial imagery data. So then we sit in the middle, basically between the data and kind of the business application or the GIS application that you have and where you want to put the results of the machine learning project. And so in the middle here, we provide really a full stack of tools and features around geospatial machine learning. So obviously we have a really strong infrastructure that is managed for you. So we provision a GPU machine automatically. You can easily scale a detector to country level or to run on the whole planet with a click of a button on your side. It's a bit more complicated on our side, but we make the heavy lifting for you. Obviously, we have some top-notch encryption and confidentiality practices, and as I said before, we are cloud-based, so all of this is kind of transparent to you. So then on top of this, let's say, geospatial infrastructure, we have a whole set of features around data management. So since we are talking machine learning, a lot of things around data preparation, multispectral normalization, and data annotation as well. So everything you need to kind of prepare a training set for a machine learning model. Obviously, this goes with some organization, access rights, data storage, data sharing, all of these nice features. And then, as we'll demo today, we are also investing heavily in having a top-notch annotation and collaborative annotation platform. And then on top of this, on top of the data and let's say the annotated data, we have a set of tools to create automatically machine learning models from your data. So we have automatic model architecture search. You might have heard the word AutoML in the industry, so that's this kind of approach. We have model training fully automated for you. As I mentioned before, there is no explicit model deployment step on Picterra, so all models are automatically available in production. So we remove the pain of moving model between the data science team and the production team. And we also have a set of tools around quality control and quality assurance that usually come after the model has delivered the detection. We also provide some visualization tools. So once you have the results of the model, you can do some analysis, for example, a change or monitoring analysis to basically visualize the results over time. And then, so this is what we provide in the platform. And then we make a lot of efforts so that you can easily integrate the results in your existing software. So maybe you're using ArcGIS to manage your GIS data. Maybe you have a custom BI tool, so like Power BI or Tableau or something like this. And so we have a lot of export option, API, and integration to kind of make it easy to take your machine learning project, take the results and put it in the next step of your internal business workflow, let's say. Cool. So that was let's say the overview of the platform and what we provide. So now I want to dive a bit into some of the new features that we've been working on, and in particular, we wanted to put the spotlight today on collaboration. So this is a very important feature to us because talking to users, and we've been talking to a lot of users over the past 6 months to 9 months. And we see there are more and more teams using the platform. So more and more teams using Picterra. And I mean, if you talk to a team, usually the first thing they want to do is collaborate. So we get very often the question of, okay, how can I build a detector with my colleague, or get some input from this colleague who's an expert on the subject matter, and so on. So really we are building and investing heavily in collaboration to foster the teamwork that we want to see happening on Picterra, and that users are interested into. If you look at the platform, we have 3 main, let's say, areas where we have collaboration features. So the first area on the left is user and project management. So things like access control, inviting new users, creating groups, teams, and things like that. Then we have detector collaboration, and we will demo this in a minute. So I think it will be clearer in the demo. But it's the whole subject of how you can collaborate on creating a training data set. And then we have results collaboration. So this comes after you've run the detector at scale and you're reviewing the results, how you can use some of the collaboration feature to also speed up the quality control process. So on users management, we have, I think, a bit the typical user management feature you would expect from a SaaS product. So you can have an organization. Within the organization, you can have multiple users. We have access control, so you can give access rights to user. You can pick who has access to what project. You can share detector and project among your team, and obviously you can also do some usage and audit logs analysis to see who's doing what on the platform, and who's consuming processing credits and things like that. On the another area where we have in collaboration, which is both in training and on results, is what we call markers. So what we call markers is a located comment, if you want, on an image. So it's a small flag here that you have on the image, and then you can have a discussion on this specific marker. So really, it's a way to also tag your colleague and bring your colleague into a discussion. And maybe you want the input from an expert or even a client. Actually, we've seen people, users do this with clients to get kind of the client input on a specific area or specific detection or something that is tricky to annotate, for example. So markers are really one of the cornerstone of collaboration, and it's a way to have a discussion with your team when you're working on a training data set. And finally, one of the main area where we have collaboration is when you're building a training set or building a detector. So up to now, building a detector on Picterra was something you would do alone, basically. So you would be alone in your detector, creating your training set. And now we are bringing today the ability to have multiple people collaborate within a detector. And so you will see in the demo, but you can see what your colleagues are doing in real time. So like in a live update fashion, and you can see what they are annotating. You can discuss with them and ask them for input or for help on some area of the image. And you can also use markers for some task management functionality, which is quite key when you collaborate. So before we jump into the demo, just wanted to highlight a bit the area that we've been working on, and that I will demo in the following minutes. So on one hand, I will start with the collaboration. So it's the main feature today. So we'll spend quite some time looking at the real-time collaboration and how we can use this to build better detector within Picterra. But then we'll also look at some of the multispectral support we have, some of the additional ways we have put in place to access data sources, and also some improvement we made on the detectors and the export of annotation. So let me switch to the platform.
Great.
I will let Monica introduce the demo.
Great. Thank you so much, Julian, for giving the introduction and the overview. So now we are already in the platform. I think just to set a little bit the scene of what we're looking at, I mean, imagine for a minute that we are in a forestry management company and Julian becomes a project manager that it's, for example, working on an ESG report. So, I mean, for such a report, you can think of a multitude of different parameters that could be used and will provide some insights to actually create a meaningful results. What we see here right now, in our case, we're looking at the custom detector that is created on Picterra platform, and it allows to extract information on, for instance, statistics of land use classification and land use change. And I leave it now to Julian to give you all the details.
Cool. Yeah. So as Monica said, this is a land use detector. You can tell by the fact that we have 5 classes in this detector. So we are looking at different kind of crops, so young crops and mature crops here. Also trees, like a generic tree class, and then roads and buildings as well. So really, we are doing a typical kind of land use detector here. I think one thing that's interesting to look at is that you can see that there is somebody else in the detector. So there is my colleague Stefan, who has entered the detector at the same time as me, and so I can see on the right top right here that he's also looking at this detector, and I can also see basically his mouse as he's moving the mouse around, so I can see what he's doing, what he's looking at, and start collaborating with him. So to show a bit what collaboration can look like, I will start with a new training area here that we will annotate with Stefan. So I'm gonna work on the trees, annotating the trees that I see in this area. And meanwhile, you can see that Stefan is working on the buildings, so I can really see live what Stefan is doing within this detector, and likewise for him, he can see as I'm drawing the trees, he can see the annotation that I'm drawing, and so you can see this is very, let's say, very seamless way to collaborate within a detector, because you have live feedback on what the other user is doing. One thing that's interesting here is I can see that he used the wrong class for the buildings, actually. So he labeled the buildings as young crops, but he should actually have used the building class. So I can very easily say, okay, this is the wrong class, so I'm going to change the class of his annotation. So I can easily correct what he did wrong.
Can you communicate with him directly?
Yeah, that's a very good question, actually. So I can actually communicate directly with him through the markers that I have mentioned before. And the way you do this is I select the marker tool, and then I can create a marker here with a category. So I will use we have a category already for things to review. And here what I can do is I can mention Stefani's marker in the comments. So if I type Stefan, the class seems wrong, and you check. What will happen is on his screen, he will see the marker, and then he will, let's say, real time, he will see my comment, and he can actually answer to the comment. So you can see that he just answered my comment, and now I can see him working on the annotation and changing the class. So that's really a way that you can use marker to pinpoint areas where the detector or the training dataset could use some improvement. And then once you're done with the marker, you can resolve it, and it goes away. Another use of the markers that is very interesting is for some task tracking. So typically what you want to do when you're building a large detector is you will have many training area across many images that you need to annotate with your team. And so you can use marker to kind of distribute the workload across the team. And you can see here that Stefan just created a red marker where he mentioned me and kind of asked me to annotate this area of the detector. And this is a way we have a cool feature to use this for task management, because I can easily go through all of the marker where I am mentioned on this image. So if I enable the mention only checkbox on the widget at the bottom here, I can easily go through the marker on the image where I am mentioned, and then as I tackle them, I do the task, I can resolve them, and it's a way that I can know how many tasks I should tackle in this detector. So really, I think the message here is you can use marker as a very flexible way to organize, either to review your training set or to do some task management within your detector. I should also mention that if you have some feedback, some requests, we are still working on this and we plan to improve this. So don't hesitate to reach out and kind of give ideas and feedback. We are always very happy to listen to this. So right, so that's collaboration in the detector training phase. So when you're building your detector, you can invite colleagues and have multiple people working on the detector in a simultaneous fashion. The other area of the platform where you can collaborate is on the results. So this is an example of a large-scale solar panel detector that we run on the city of Hayward in California. So you can see that we run it on the whole city on the WMS image that is made publicly available by the city. And what's interesting here is I can zoom in on the detection, and some of the detection are good, some are actually less good, or they are, let's say, false positive. So for example, you can see these ones look like false positive. It seems the detector is mistaken the shadow of the roof for a solar panel. And what I can do here with marker again is I can put a marker and I will put a to-do category, and I can say this is something we should bring back into training. And so I can make notes like this as I'm going through the detection on the detector, and annotate different areas that might be interesting to bring back in training. For example, this one is working fairly well. You will see, so I added a marker that this is a good one. So markers are also a way, when you're looking at the results in the quality control phase, to remember what could make sense to bring back in training when you're iterating on the detector once more, right? And this is one of the key aspects of Picterra, is we want users to not only build a detector once, but to build a detector once and then iterate on it until it reaches your accuracy expectation. And so markers in detection are a way to keep track of what you should consider adding to training to make the detector even more robust and working well at scale, let's say. So yeah, that's two areas where you can use markers and collaboration in the platform right now. So either in training, on the training phase, by speeding up the training and getting some inputs from colleagues on the training, but also when you're looking at the results and you're more in a quality control phase, you can also use markers to kind of highlight areas of the image that are interesting to look at, or that you want to bring back in training for the next training iteration. So now, besides the real-time collaboration, and I wanted to go through a few additional features we have on the platform. So the first one is the organization view. So this is really the cockpit to manage your organization on Picterra. You can see that I have an organization with quite a few users. So I can see the list of my users, and I can also remove users, edit users, delete them if they are not working for the company anymore. I can also add additional users, excuse me, and invite them to the organization. So really, this is the way to manage access when you're an admin within a Picterra organization. You also have a list of all the projects within the organization, so I can see what projects are within this organization and who has access to what, and I can see the users. I can also click on the detail here, and there I have a detailed access control view of this project, and I can select which user has access to which permission on this project. So there is 3 permission. View is read-only, so they can only look at the data. Modify the user, they can upload images to the project or run detectors. And then manage, it allows users to invite other users within the project. So really it's quite a flexible permission scheme that you can use to give access to different projects or detectors. And on the left here, you also have, I mean, the same thing for detectors, where you can look at all the detectors within the organization and kind of manage the access. The same for the images that you have within your organization. And then the more audit logs oriented features. So looking at the usage and the API usage from your users. So really, this is the cockpit to manage your organization within Picterra all by yourself. Cool. The last thing I wanted to go through while we are looking at the platform, and this one is not collaboration related, but is more on the data side, is some of the new features we've been working on, trying to allow more data to trying to simplify bringing data into the platform, let's say. So there are multiple ways to get data into Picterra. The typical way is uploading the data. So if you have a GeoTIFF file from a photogrammetry software, from a drone service provider, from a satellite provider, and so on, you can drag it and drop it on this screen and upload it to the platform. So that's the typical way to get data into the platform. One thing we've been adding quite recently is the support for multispectral images. So if you tick that box here, when the image is uploaded, we'll handle it as a multispectral image. And what this will do is, if you look at the image detail afterwards, you will have a multispectral information here. And you can look at the image and specify how we should visualize it. So here you can see that this image has actually 4 bands. The fourth band is an infrared band, and I can change the way that the bands are mapped to the channel on the screen. And here you can see that I have a kind of a false color image, where you can see the vegetation is red in a typical infrared image. So this UI is a way to manage the band mapping. You can also, if you have very specific multispectral images that have different ranges for different bands that needs to be interpreted differently, you can also use this to put different values for each band, and then you can preview what it looks like on the right hand side here. So you can really have a very fine control on the way the bands are normalized and interpreted by the platform. I think what's interesting to mention here is that the visualization, I mean, obviously you can only visualize 3 bands at a time because we see only 3 colors on the screen. But the machine learning model will use all the bands that are in your image. So if you upload a 50 band image on the platform, the machine learning model will learn from the 50 bands, not only the 3 that you visualize. So that's one cool new feature. If you're dealing with multispectral, hyperspectral data, you can really upload it on the platform and work on it. The second way to get imagery into the platform is what we call imagery server. And so this is typically the WMS server, like XYZ server that you have available. So this is an example where I'm connected directly to SwissTopo, which is the Swiss government WMS server, and they make 10 centimeter imagery available for the whole country as an open data product, actually, which is pretty cool. And you can see that I can stream this data, I can navigate on the map and directly access this data from the SwissTopo servers, and then I can import a specific region to work on my detector, either to build a detector, so create a training data set on this, but also detect at scale on the whole country if I want to. So this is a very interesting feature. So you can either connect to public server. So this one is a public server. But if you have a private imagery server, so for example, you have ArcGIS imagery server within your organization, we have the ability to connect to any WMS server, basically. So here we have you need to enter a few technical details, and we are happy, the support team is happy to help you with this. But basically reach out to us and we can connect to whatever imagery server you have already in your organization. So yeah, that's the second way to get data in Picterra, and it's quite a powerful way if you have imagery server that are already set up. You don't need to re-upload all of your data. And then we have the third way to import data, which is around cloud storage, let's say. So if you have your imagery stored on Azure cloud storage in an Azure bucket, or on Amazon S3 cloud storage or Google cloud storage, I mean basically any of the big cloud provider cloud storage, you can generate a URL, so a link to the data, and then you can import it within Picterra through this user interface. I think here it's important to mention that also you can do this through the UI. Usually, if you have data on cloud storage, you will have I mean, 1,000, 10,000 of images. And this is something you want to automate. And so we have an API to automate this. So this is also something you can automate through the API, so you can easily import a whole bucket of images into your Picterra account. Cool. Yeah, that was it for the product demo. So I'm gonna go back to the slides.
Thank you. I think it was quite useful to see, a hands-on kind of real life experience on how those features actually look like. And we've talked about the collaboration features, and you showed the markers, the comments, the way that the multiple users can actually enter the detector and do annotations at the same time simultaneously. So I think the next slide in the deck that we have, if you can go through, just tell us why is it important. I think at the end, all of those features are there for a reason. So what do you think are the main reasons why the collaboration features are needed in a machine learning platform? Yeah, right. Good. I mean, yeah, good question. And obviously we don't build this just because we think it's cool or something like that. But I think there is really two main aspects to why collaboration is important. I mean, the first one is around efficiency. So by having multiple users collaborate on the detector, you can parallelize the work. So you can have one user working on one image, the other one working on another image or on different area of the same image. And it's a way really to go faster and to work in parallel on the detector. And as we've seen with the marker, you can also use the marker to do some task tracking. So it's a way to be more efficient. But then I think there is also an aspect which is around quality and kind of really collaborating as a team. So usually what we see is if you the team that are working on Picterra, they might have different expertise, or they might have different, let's say, slightly different opinion on how to tackle a specific detector or a specific project. And so by allowing collaboration, it's also a way to have discussion. And maybe you have someone who's the expert on the subject, and you want to easily bring them in the detector to get their input on a specific area or on a specific object, and kind of ask them, is this really what we want to detect, or should we do something differently? So it's also a way within the team to make sure that everyone can get involved, and that you can basically leverage the skills of everyone in the team, besides just the pure speed. And I mean, at the end of the day, the whole reason we are doing this is, and the whole reason for, let's say, the Picterra platform is always to put more project in production faster. So we are really looking at removing all the roadblocks you have that are slowing you down when you try to bring a machine learning project in production. And collaboration is one of the way to make this more efficient and faster. Yeah, so I mean, to wrap it up, so we've seen what we've been working on in the last few months, really, and the collaboration push, and we'll continue working on this. But I also wanted to take the time to look at what's coming up next, and what are we working on right now on the research and development department. And so one of the big feature we are working on is what we call data curation and model analysis tools. And this might sound a bit complicated, but really where this is coming from is when talking to users, at some point they reach a point in their machine learning project where they want to improve the detector, but it's unclear what they should do. So adding more data doesn't help. It becomes a bit of we don't really know how to improve a detector beyond a certain accuracy. And I mean, this is not just a problem on Picterra, it's like an industry-wide problem that nobody has a good answer for. But what we are working on is some tools, some visualization tools to guide you into getting recommendation on how to improve your dataset. And the way we are tackling this is that by understanding the dataset better, so for example, by understanding the different lighting condition you might have, or the different seasons the image were taken at, or different sensor resolution and so on. So you have all of these variables in your dataset, and we try to make it easier to understand them, and then use that to guide you into building
building a better detector really. And so we'll release in the next few weeks or months some visualization feature to allow you to visualize your data set and guide you through the process of building a better detector.
Thank you, Julian. I think that concludes the part of the presentation, and I'm just checking the time. Yeah, we have about 10 minutes, so right on time. We've received a couple of questions. In the meantime, I'm just trying to group some of them together. So there is a question about the collaboration on the detector. So how is there a limit of how many users can enter the detector and concurrently make changes to annotations?
Yeah, that's a good question. There isn't a limit currently. I mean, honestly, we haven't tested with thousands of users, but there is not a limit. Like if you have 10 users, 20 users in your organization, we are happy to support that, and there is no limit on that front.
I think I'm trying. Let's go through a few questions that we got about the collaboration first, and I also saw some about the detectors itself. So can you collaborate on editing the result, or is it limited to training?
Yeah, so right now it's limited to training, but this will change shortly. So that's one of the next thing we are working on. So right now the collaborative editing is limited to training, but we are looking at extending this throughout the platform, also on the results editing.
Mm-hmm. Great, thank you. Also, a very practical one. So what happens when someone starts to train a detector while I'm working on it? So when somebody works on it and then somebody else wants to train it, what happens then?
Yeah, so you will get a notification on the screen. So there is a few actions that if you do them in a detector, the other colleagues working on the detector, they will get a small notification on the screen. So for example, if you import a large amount of annotation and they need to reload the detector, it's something we'll notify people about. And training is one where you'll get a notification. And actually, if someone has modified the detector in the last 30 seconds before you start training, and you might risk kind of training on a half finished dataset, you also get you get a warning about this. So really, we try to surface all of the actions of the other users.
Mm-hmm. Thank you. And I think I have another one about the practicalities of how the whole process works. How can I be sure when I train a detector that it has picked up all the latest changes from everyone?
Yeah, so that's that. So what we have for this is we have a warning, like if someone has modified the detector in the last few minutes before you click train, you will have a notification telling you that it might be good to check again that they haven't changed something important, let's say. But yeah, that's what we have for now. I think it's also an area of improvement, and happy to hear any feedback on these points.
Thank you. We also had some questions about the detector. So at the beginning, you showed the detector which included different classes. There were trees, there were crops, there were roads. So the question was, did those classes belong to the same detector, or did they belong to different detectors?
No, yeah, so it's the same detector. So we have multi-class detector on the platform. Actually, it's something I forgot to mention, but good that you asked the question. But we recently went from max 5 classes in a detector to 10 classes. So you can create a 10 classes detector inside the platform, and then on the machine learning side, it's a multi-class. It's a multi-class detector, really. So yeah, it's the same detector detecting the 10 classes.
So on the multi-class versus single class detector, if you can maybe just say a little bit like, when would you use which? There was also some curiosity around how to choose the best one for the job.
Yeah, I think it's a really good question. It's also it's a bit of a challenging one, even on the machine learning side. I think what we have seen, to give a few thought or a few tips on this. So typically, if you're doing land use and you're trying to classify let's say the whole image, so every pixel should be classified in something. So if you do urban versus forest versus roads, for example, you expect all of the pixels in the image to be assigned to a class. In this case, it makes sense to do a multi-class detector because yeah, you don't want to run 10 different detectors, but you want to run a single detector. I think the other case in which it makes a lot of sense to do a multi-class detector is if the objects are somewhat related. So I don't know if you're detecting different type of trees, for example, I don't know, pine trees and coconut trees or something like that. It makes sense to do a multi-class detector because it's kind of the same kind of object. They have somehow more or less the same shape and so on. But now if you're doing something like different objects that are completely different, so I don't know if you do buildings and water, like lakes and water area, then it might not make much sense to do a multi-class detector because the objects are so different than having a single class one specific to each object might work better. So yeah, I think it depends a bit on the similarity of the object within the multi-class detectors.
Thank you, Julian. And then I think it's looking at the time, probably the last question for this Q&A. It's around the types of imagery that we support. So specifically, the question is, do you support hyperspectral imagery?
Yeah, so we do actually. So to us, hyperspectral and multispectral or multiband are all the same. So I mean, a hyperspectral image is an image where you have, I don't know, 50 bands or 200 bands. But yeah, this will be supported in the platform. So you can upload a 50 bands image or a 100 bands image. And then the detector will actually learn from the 100 bands image. And I want to mention, I mean, if you're doing this, I think it's not something we've seen a lot of users do. So it's always interesting to us also to know that you're playing with hyperspectral image, and we would be happy to kind of learn along the way as well what could be improved.
Thank you, Julian. I think that's it for the questions for now, and we are near the end of our designated time. So I think with that, I'd like to say thank you for everybody who joined us today. I hope that this session was informative, and we're looking forward to inviting you and having you around for the new and next upcoming product webinars that we will be releasing in the next quarter. Just to recap, I think the recording from this session will be available, so you'll receive it via a follow-on email. And if you want to contact us or find any additional information about Picterra, it's available on our website. Thank you again, and just wish you have a great rest of the day. Is it morning or afternoon for wherever you are? We're looking forward to connect with you again. Thank you.
Thank you, guys. See you next time.